Structural analysis. Good day, everyone, and welcome to today's lecture on structural analysis. In this topic, we will study how engineers evaluate structures to ensure they can safely carry loads without failure. Structural analysis is a fundamental part of engineering design because it helps us understand how forces are distributed throughout structural members. Throughout this lecture, we will focus on trusses, frames, and machines. We will learn how to determine internal forces using the method of joints and the method of sections, identify zero-force members, and analyze both two-dimensional and three-dimensional structures. By the end of this session, you should be able to apply equilibrium principles to solve common structural analysis problems encountered in engineering practice. Objectives. Today, we will discuss structural analysis, focusing on trusses, frames, and machines in statics. Structural analysis helps engineers determine how forces are distributed throughout a structure and whether it can safely support applied loads. In this lecture, we will learn the assumptions behind truss analysis, methods for finding member forces, and approaches for analyzing frames and machines. Understanding these concepts is essential for designing safe and efficient engineering structures. Simple trusses. A truss is a structure composed of slender members connected at their ends by pins. To simplify analysis, we assume that loads are applied only at the joints and that each member behaves as a two-force member. This means members carry only axial forces, either tension or compression. Simple trusses are constructed from triangular units because triangles provide geometric stability. Supports, such as rollers or rockers, are often used to allow thermal expansion without creating additional stresses. Method of joints. The method of joints is one of the most common techniques used to determine forces in truss members. The method is based on the equilibrium of each joint. Since each joint is treated as a particle, only the equations sum Fx equals 0 and sum Fy equals 0 are required. We usually start at a joint with no more than two unknown forces. Unknown member forces are initially assumed to be in tension. If the calculated value is positive, the member is in tension. If negative, it is actually in compression. Zero-force members. Zero-force members are truss members that carry no force under a particular loading condition. Identifying these members can significantly simplify analysis. One common rule states that if two non-collinear members meet at a joint with no external load, both are zero-force members. Another rule states that if three members meet at a joint, two are collinear, and there is no external load, then the third non-collinear member is a zero-force member. Although they may not carry force in a specific case, these members improve stability and structural integrity. Method of sections. The method of sections is useful when only a few member forces need to be determined. Instead of analyzing every joint, we make an imaginary cut through the truss and isolate one section. We then apply the equilibrium equations, sigma Fx equals 0, sigma Fy equals 0, and sigma m equals 0. To solve efficiently, the cut should pass through no more than three unknown members. Choosing an appropriate moment point often allows us to determine a desired member force directly. Space trusses, 3D trusses. Space trusses are three-dimensional truss structures commonly used in large-span roofs, towers, and aerospace applications. They are often constructed from tetrahedral units, which provide stability in 3 dimensions. Analysis follows the same equilibrium principles as planar trusses, but now includes 3 force equations: sigma Fx equals 0, sigma Fy equals 0, and sigma Fz equals 0. When using the method of sections, moment equations about the x, y, and z axes may also be required. A Cartesian vector approach is often the clearest way to perform calculations. Frames and machines.
Unlike trusses, frames and machines contain multi-force members. Frames are designed primarily to support loads, while machines are designed to transmit and modify forces to perform work. Analysis begins by separating the structure into individual members and drawing free body diagrams. Identifying two force members can greatly simplify calculations. Equilibrium equations are then applied to each member or subsystem while ensuring that action-reaction force pairs are represented correctly at all connections.
General tips. When solving structural analysis problems, always pay attention to force directions and sign conventions. Carefully distinguish between tension and compression. Verify all geometric information, such as lengths, angles, and coordinates, before performing calculations. A well-drawn and clearly labeled free body diagram is often the key to avoiding mistakes. Finally, use equilibrium equations strategically and choose the most efficient approach for the problem being solved.